So now let's learn more about regular polygons. So again, we said last time that a regular polygon is a polygon that is both equilateral and equiangular. And so in this example, we have a hexagon. Now that's a regular hexagon, and we're going to assume that all the sides are equal. So the center of the circumscribed circle, okay, which contains all the vertices of the polygon, is also the same as the center of your regular polygon. Now, when you draw a line segment from the center to any vertex on the regular polygon, you're forming a radius. So the central angle here, this one, is actually the angle that's formed by the two radii. Now, if you make a line segment from the center perpendicular to any side of your regular polygon, you're forming the apothem. So pretty much, you can also have an apothem here. You can make a better version on your paper. So this should be perpendicular at the midpoint, right? Because these triangles should be congruent triangles. So why do we study all these terms? Well, you need to know what an apothem is. It is the height of, the base of an isosceles triangle that is formed by two radii. So as I have explained earlier, these are two radii. You're forming an isosceles triangle, right? So by HL congruence, these two isosceles right triangles are congruent. So this segment here is your apothem. So it's the height of one isosceles triangle. We need to know how to construct it and what it means, because when you are trying to find the area of a regular polygon, the formula is actually given by 1/2 times the length of the apothem times the perimeter. There you go. And perimeter is the sum of all the sides of the regular polygon. So pretty much if you know that one side is S, then just multiply it by the number of sides. Let's go 2 slides backwards. Okay. So let's have an example here on how to identify the parts and measuring, central angles. So WXYZ is a square inscribed in circle P. Identify the center. So the center is point P. Identify a radius. Well, there's a lot of possible radius, but PX is explicitly drawn. Another one is PY. The other possible radii are PW and PZ. Now identify an apothem. So an apothem goes from center, which is P, perpendicular to one of the sides of your regular polygon. So that's Q. So now how are we going to find measure of angle XPY? So divide 360 by 4. Now why divided by 4? Because you can imagine this inscribed square being split into 4 congruent isosceles triangles, right? And the sum of all the central angles here is actually 360. So if you divide 360 by 4, you're going to get 90 degrees. So that's a central angle for one isosceles triangle. Now for angle XPQ, Okay, so x and then PQ, that's actually half of the central angle. Okay, so your applicant divides your isosceles triangle into two congruent parts by HL, right? HL congruent. Okay, so then split 90 into 2 and you will get 45 degrees. And then last but not the least, angle PXQ. So PXQ is this corner here. So we know that in a triangle, all the angles add up to 180. So you can add these up and then the remaining will be your answer. Or if this is a right angle, then the two remaining angles of the triangle are complementary. So you can just subtract this from 90 degrees and you will also get 45 degrees. Okay, do they end up to be equal all the time? No, not necessarily. So don't assume that half of the central angle and that base angle right there are always congruent. So depending on what type of polygon, what type of regular polygon you have, the angles may vary. So let's look at another example. We have a regular pentagon here. So first let's measure AFB, which is your central angle, right? So we said earlier, divide 360 by the number of sides. We have a pentagon, so that's divided by 5. Okay. So the measure of the central angle is 72. Okay. Next, AFG. So again, this is an isosceles right triangle. Your applicant divides that, into 2. So that's actually an angle bisector. So here you go, 72 divided by 2. You get 36. And last but not the least, GAF. So we can subtract the measure that we got here from 90 degrees, right? So you get 90 take away 36. That's equal to 54 degrees. Because we know that these two angles are complementary, or if you add all these three angles in the triangle, they add up to 180.